Hello, everyone. So the product and quotient rules are rules for describing, as you might guess, how to differentiate the product of two functions and how to differentiate the quotient of two functions. So our strategy is going to be pretty much that we learn derivatives of a couple of functions and then we learn ways to put them together to get way more complicated functions. And this should be a pretty easy topic in that there are two key formulas that we need to understand and know how to use. But as long as we can use those two formulas, that's pretty much all we need to do. We just have to be a little bit careful that our intuitive, what we might guess is not true. So it's not true that the derivative of a product is the product of derivatives. And it's not true that the derivative of a quotient is the quotient of derivatives. Instead, there are two formulas that we need to pay attention to and memorize and learn how to use. Okay, so let's get started. So if start with the product rule. So let's suppose we have two functions and then we know that they're differentiable. So they're going to be, functions that are in some list of functions whose derivatives we already know. If we can differentiate the individual functions, then we can differentiate the product, and the derivative of the product comes from this formula. So the derivative of f times g is f times the derivative of g plus g times the derivative of f. So what this is saying is that we fix the first function and differentiate the second, and then we fix the second function, differentiate the first, and then we add those two things together. And that's the derivative of our product. And if you want to say it also in prime notation, equivalently, you could say fg prime is f times g prime plus g times f prime, right? So we fix the first, differentiate the second, and then we fix the second and differentiate the first. So as a warning, notice this is not the product of derivatives, right? The derivative of the product is not df over dx times dg over dx. It's not f prime times g prime. So please don't do that, or you'll get the wrong answer. So every year, a couple of people do that. You think it won't happen to you, just make sure it doesn't. So you have to use a product rule. It's not the product of derivatives. That will give you the wrong answer. Okay. So why is this true? Why is there this complicated formula? Even though, like, for limits, the limit of the product was the product of the limits. Why do we have a more complicated formula with derivatives? So let's suppose we have two functions f and g, and p of x is the product, so p for product. And let's suppose we want to differentiate p. Then the only thing we can do, if we don't already know the product rule in advance, the only thing we can do is to go back to definition, right? We have to look at p of x plus h minus p of x divided by h. Take the limit as h goes to 0. That's the definition of the derivative. So we look at p of x plus h minus p of x divided by h. And then we sub that in for what is our function p. So our function p is f times g. So p of x plus h is going to be, everywhere we replace the x by x plus h, is going to be f of x plus h times g of x plus h. P of x is just what we had before. So we get this expression, and then I write it in this strange way. So the question is it equal, and why did we do that? So it is equal if we were to multiply out the terms. You see if everything is divided by h on the bottom. And if we multiply the terms, we get g of x plus h times f of x plus h, which is in what we had before. Then we get an extra term minus g of x plus h times f of x. But in the second term, if we multiply it, we get plus f of x times g of x plus h. So those are going to cancel. And then we have finally minus f of x times g of x, which is in what we had before. So it is equal to what we had before. And the advantage is that now if we write it this way with this trick, we can take the limit of everything. So if we look at f of x plus h minus f of x divided by h, for instance, if we let h go to 0, that by definition goes to the derivative of f. And similarly over here, if we look at g of x plus h times the g of x divided by h and let h go to 0, then by definition, that is the derivative of g. So that is going to g prime of x. And then let f of x does not depend on h. And lastly, we have to think about g of x plus h. Well, g was supposed to be differentiable at x, so it's also continuous at x. Remember, differentiable implies continuous. So if we want to take the limit, we can just sub in. So this is going to go to g of x if we substitute h going to 0. Okay, so in the end, we get g of g times f prime plus f times g prime. It's exactly what we said for the formula for the derivative of the product. So that's why we get this formula out of that. Okay, so for example, here's f of x is x times e to the x. We know how to differentiate x. We know how to differentiate e to the x. So we should be able to use the product rule to differentiate the product x times e to the x. So let's use the product rule. We fix the first function x. We differentiate the second, which is e to the x. We fix the second function e to the x. We differentiate the first function x. So I split it up into two steps just because it's easier to think about doing one at a time. So here I write d over dx of e to the x in place of having to differentiate e to the x, and similarly here, d over dx of x. And then I actually did the derivatives on the next line. So we get x e to the x plus e to the x. So if you had some complicated functions, for instance, splitting it up would stop it from becoming too confusing. Okay, so the derivative is x times e to the x plus e to the x. And notice this was not the product of derivatives, right? So if we just naively done the product of derivatives, we would have done 1 times e to the x. Okay, that's not the same thing as the derivative f prime of x. So the product of derivatives would not work even in this simple example. Okay, so we really have to use the product rule. And okay, just for just that example, we could keep differentiating this, right? We could do the second derivative by differentiating the first derivative. So we would have to differentiate x e to the x, which we already did. We would get x e to the x plus e to the x. And then we have to differentiate the e to the x. So we would get x e to the x plus e to the x. That will give us x e to the x plus 2 e to the x. And we could differentiate again the third time. Differentiating the x e to the x from the second derivative gives us x e to the x plus e to the x. Differentiating 2e to the x gives us 2e to the x. We add them together, we get x e to the x plus 3e to the x. And similarly, you could find a formula for the nth derivative. Okay, so if you just take a random function, it's quite hard to find a formula for the nth derivative. But with simple examples like this, especially with things like polynomials and e to the x, then you can find a formula. Okay, another type of example could be with the product rule where instead of giving you a formula for the functions, they give you, say, a table of values or a couple of values of the function and derivatives, and then they ask you to compute the derivative of the product or derivative of the quotient, something like that. So here, for instance, f of 5 is 1, f prime is 6, g of 5 is minus 3, g prime of 5 is 2. Let's find f g prime of 5. Okay, all we have to do is use the product rule, right? So the product rule says we fix the first, differentiate the second. We fix the second, differentiate the first. We evaluate everything at 5. Okay, we know all these numbers, so we can substitute them in. So we get 2 minus 18, we get minus 16. So this is another possible example. Okay, so let's move on to the quotient rule, and the idea is the same. So if we have two functions f and g that we know how to differentiate, then we can differentiate the quotient f divided by g according to this formula. So it's a little complicated, but it's just a formula we have to know and learn how to use and just memorize and use this formula. So notice it's not f prime divided by g prime. It's not the derivative of the top divided by derivative of the bottom. So please don't make that mistake. Instead, we have to do the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. So here, this is the bottom squared, not the second derivative. And be careful with the signs here. So often people get the sign confused and they interchange these two. With the product rule, it didn't matter which order we did it because there was a plus and it doesn't matter what order you add things. But if we swap these around, we'll swap the sign by a negative sign. So you'll get negative of the correct answer. So make sure you do g f prime minus f g prime divided by g squared, or bottom times the derivative of the top minus top times the derivative of the bottom divided by the bottom squared. So not the question of derivatives, as we said. So for instance, here is an example. If y is x squared minus 2 divided by 2x plus 1, find dy dx. So remember we said that we can't split fractions along the bottom. So there's nothing we can really do to simplify this. I mean, we could split the top, but it doesn't make it easier. We cannot do anything to simplify the 2x plus 1. So we really need to use the quotient rule. Yeah, so we know how to differentiate x squared minus 2. We know how to differentiate 2x plus 1. So we should be able to differentiate the quotient using the quotient rule. So let's do that. It's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. So we just memorize the formula, plug in what it is in our function. Okay, and then on the next step, I actually did the differentiation of the pieces. So x squared minus 2 becomes 2x. The derivative of the 2x plus 1 becomes 2. And then, okay, if you simplify and you trust me, then you will get this as the final answer. So 2 steps. One is remember the product rule. And then the second is to actually do the differentiations that are inside remember the quotient rule. And then the next step is to actually do the differentiation inside the quotient rule. So as long as you remember the 2 formulas and remember the right ordering and how to apply it, then it should be pretty straightforward. One maybe last thing to say is there are some examples where it's easier to do a different method. So you should always choose the simplest method unless you're told otherwise. So for instance, here is x squared plus x to the 1/2 divided by x, find dy dx. Well, in this case, you could use the quotient rule because it looks like a quotient. But in this case, it will be much simpler to split it along the bottom. So split along the top. So there is only one term on the bottom. We split along the top. We get x squared divided by x, which becomes x. We get x to the 1/2 divided by x, which becomes x to the minus 1/2. And then we got rid of the fraction. We can just differentiate using the power rule. So it'd be way easier to first simplify with the algebra, and then we can just use the power rule. We get 1 minus 1/2 x to the minus 3/2. So if there is an easier way to do it, then try to avoid using the quotient rule, but sometimes you just have to use the quotient rule. Okay, so just to summarize, if we can differentiate two functions, we can also differentiate the product and their quotient. And we have formulas for doing that. And we should be careful that it's not the naive formula you would expect, right? They're slightly more involved formulas. We just have to memorize them and learn to apply them. Thank you. See you next time.